Hi ladies, this is Mrs. Blaufuss here, and this is lesson 5.6. And in this lesson, we're looking at triangles that are congruent using the two shortcuts, angle, side, angle, and angle, angle, side. So the first thing that we have to do is define the term included side. And last lesson, we defined the term included angle, which is an angle formed by two sides. Well, an included side is the side enclosed between two angles. So let's look at this first postulate, the angle side angle postulate. The angle side angle postulate is a shortcut that shows triangle congruence. So in words, this postulate says if two angles and the included side of one triangle are congruent to the corresponding angles and the included side of another triangle, then the triangles are congruent. So let's look at the diagram that we have with this. So the model has angle A congruent to angle R and angle C congruent to angle T. It also has the included side of both of these triangles, which is side AC and RT congruent. Now AC and RT are the included sides because both of them are between the two given angles. Okay, so here are our two given angles in each of the triangles, and in both of those triangles, the side that we're given as congruent to the other side in the other triangle are both included sides. So when we write our congruent statement, again, it doesn't matter where you start. Okay, just like when we've been writing these congruent statements, it doesn't matter where you start as long as you make sure to match up the corresponding parts. Okay, so when I see angle side angle, since it's angle side angle, I'm going to start with an angle, then I'm going to do a side, then I'm going to do an angle. Okay, so I'm going to start with A. So angle A is my one arc angle, so my angle that's marked with just one congruence arc. And then AC is my side, and angle C is my other angle. You know, the only vertex that I didn't use is B. So I have to make sure to list all three vertices. Okay, and that's congruent to angle R, or triangle RT, and then my non-included unmarked vertex. Now, again, you could write this other ways. So another example might be triangle ABC is congruent to triangle RST. And what I have to make sure that's true is that angle A matches up with angle R, which it does. I have to make sure that AC matches up to RT. So here's AC, my first and third position, and RT, my first and third position. And then lastly, that angle T matches up with angle C. Okay, so all of those things are true. So however you write your congruent statement, just make sure that all corresponding parts match up. So we have this term included side. So let's think of, just like what we did when we were looking at included angles, let's look at which sides would be included with which angles. So for example, here, BC is the included side of angle B and angle C. This side right here, AC, AC would be the included side of angle C and angle A. And then lastly, AB would be an included side of angle B and angle A. Okay, so those two angles are on each endpoint of the segment. So that's our angle side angle postulate. Now the second postulate that we're looking at in this lesson is the angle angle side postulate. And this angle angle side postulate does not deal with included sides or angles. Okay, so here we can say if two angles and a non-included side of one triangle are congruent to the two corresponding angles and non-included side of another triangle, then the triangles are congruent. So now if we look at our diagram, we have A and C as our two given congruent angles to R and T respectively, and then BC is congruent to ST. Well, in our angle side angle postulate, we would need ST and BC to be the included side, but in this angle angle side postulate, we have an angle, and a side. Okay, so that's sufficient information here to use this angle angle side postulate. We have two adjacent angles and a non-included side, congruent to two adjacent angles and a non-included side. And these non-included sides and angles all correspond within the two triangles. So A corresponds to R, T corresponds to C, and BC corresponds to ST. So we can write a congruent statement. Again, find a way that works for you, but just make sure that your corresponding parts match up in the two statements. So I'm always going to start with my angle, then go to another angle, and then do my side. So triangle ACB is congruent to angle R, angle T, and side TS. So R, T, S. So again, if you want to write it a different way, that's okay. I'm going to just give one more example of how you could write this statement. So triangle ABC would be congruent to triangle RST. And when you write this statement, again, just make sure that A and R are in the corresponding positions, that C and T are in the corresponding positions, and then lastly, that BC and ST are in the corresponding positions, okay, which in both statements they are. So let's look at how we can define non-included side. So remember, the included side would be the side in between the two given angles. Well, a non-included side, let's say BC, so BC would be the non-included side of angle B and angle A. BC would also be the non-included side of angle C and angle A. Okay, so because both of those are the only angles it is included are B and C. Okay, so B and C as a pair are the two angles for which BC would be an included side. So any other combination of angles, BC is a non-included side. Okay, so far we've looked at 4 different ways where we can show triangles are congruent. So some ways that work from 5.5 are side, 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 and side, angle, side. So 3 congruent sides correspond to 3 congruent sides are congruent to the 3 corresponding sides in the other triangle. Or side, angle, side, where we have a side, an included angle, and another side, congruent to a side, an included angle, and another side. So side, included angle, side, or side, side, side. And then today we looked at angle, side, angle, where we had an angle, an included side, and another angle. And then lastly, angle, angle, side, where we had an angle, another angle, and a non-included side. Okay, so those are all ways that show congruence. Okay, so these all work. Now, some that we haven't talked about but that do not work are side, side angle. That information, if you have 2 sides and a non-included angle, that will not show triangle congruence. One way that is easy to remember is if you read it backwards, it spells a bad word. Okay, so that's just your like anecdotal reason to not use this. But I'll link a video down in the comments for the whole explanation, the proof as to why that is not a triangle congruent shortcut. And then the second reason, or the second shortcut that does not work for triangle congruence is angle, angle, angle. And just a quick way you can think about why this doesn't work is that we can have an equilateral triangle or an equiangular triangle. We can have it this big, or we can have it this big. In both of those, all of the angles are congruent, but you can see that those sides are not congruent. Okay, so those are the 2 shortcuts that do not work for triangle congruence. All right, let's go through a couple examples. So in this first example on your note sheet, we're looking at triangle PQR and triangle KJL. Okay, the first thing that we need to do is change this statement. Your note sheet has a typo. So this should say side, it should say side PQ is congruent to side LJ. So if all of 3 of these statements are true in the 2 triangles, we need to write a congruent statement for the 2 triangles. So the first thing I'm going to do is just draw 2 triangles. I'm going to first decide whether or not they're congruent. Okay, I know that angle R is congruent to angle K, so I'm going to mark those congruent. I know that angle Q is congruent to angle L, and I know that QP is congruent to LJ. Okay, now I have my triangle PQR and I have my triangle KJL. So now I have to determine whether or not these are congruent. Well, I have 2 angles and a non-included side, so I can use the angle, angle, side shortcut. And when I do this, I want to make sure to match up R and K. I need to match up Q and L, and I need to match up QP and LJ. So my triangle congruence statement looks like this. R triangle RQP is congruent to triangle KLJ. Okay, so R and K match up, Q and L match up, and QP and LJ match up. All right, in the second example, it says angle D is congruent to angle N. So again, first thing I'm going to do is draw my triangles. And I know that D and N are congruent. I know that E and L are congruent. And I know that DE and NL are congruent. Now, in both of these triangles that I just drew, I'm missing a vertex. So I have D, I have E. I need to label my last point F. Here I have L, I have N. I need to label my last point M, just so that I don't miss anything in my statement. Okay, so looking at this, I have an angle, a side, and an angle. And then in the second triangle, I have an angle, a side, and an angle. So I can use the angle, side, angle shortcut for this to write a congruent statement. So I can say angle or triangle DEF is congruent to triangle NLM. Okay, so D and N have to match up, E and L have to match up, and then the unmarked non-included angle has to match up. So F and M need to match up. All right, let's try a few more. So we're going to look at the two triangles and we're going to determine whether or not the triangles are congruent. So if I don't have a reason as to why they can be congruent, then if I cannot give a reason to why they are congruent, then they're not congruent. So let's look here. In this first triangle, I have a side, an included angle, and another side, a side, an included angle, and another side. So that's my side, angle, side. And when I write my congruent statement, I want to make sure to match up my corresponding parts. So I can say triangle DBA is congruent to triangle DBC. And I can go through my statement and make sure that B and B match up, that AB and CB match up, and that DB and DB match up. Okay, so DB is a shared side, so it's congruent to itself. All right, in this next triangle, I have a side, and an angle. Now, if you remember from that table that we created about ways congruent shortcuts work and which ones don't, this would be side, side, angle, which is not a congruent shortcut. Okay, so here we can say cannot be determined. Okay, and then this next one, we have an angle, we have another angle, and a non-included side. And here's an angle, and a non-included side. So we can use the angle, angle, side shortcut or the side, angle, angle shortcut, however you remember it. And let's start by naming our angles. So A and F are congruent angles. So they have to go in corresponding parts for our statement. And then B and D are congruent. And then lastly, BC and DE are congruent. So triangle ABC is congruent to triangle FDE. All right, and then our last example, we have an angle, an included side, and an angle. And then in our second triangle, an angle, an included side, and another angle. So here we're using the angle side angle postulate. And I'm just going to go by 1 tick mark and 2 tick marks. So my 1 tick mark is angle H, and that's congruent to the other triangle that has 1 angle arc, which is angle K. And then HG is congruent to is congruent to KJ. And then lastly, my unmarked, unincluded angle is I and L. Okay, so angle J matches with angle G, side HG matches with side KJ, and angle H and angle K match. Okay, so yes, I can determine that these two triangles are congruent by angle side angle. Okay, try this last part on your own. You can pause the video while you work, and then you can unpause for the solution. Okay, and lastly, here are the solutions for the on your own portion. So again, the only one that we cannot determine is the one that has an angle, angle, angle given information. That is not a congruent shortcut. Therefore, we cannot determine that those two triangles are congruent. We would need a little bit more information. If we had just one of these sides congruent, then we could show that the triangles are congruent. But since we don't have that, then we cannot determine triangle congruence here. So please jot down any questions or notes that you have, and we can go over them next time I see you in class. Thank you.